All right, let's get right into it. Every now and then a research paper drops that has the potential to just completely change the game. And today, we're looking at one that might be exactly that, the next huge leap for AI. It's a totally new way of thinking called nested learning. Now, that is a seriously bold claim, right? But it's one that's really starting to bubble up in the AI community. While everyone was busy watching the latest chatbot bake-off, Google published this paper that some are calling Attention is All You Need Part 2. Basically, a fundamental rewrite of how AI learns. So, what did everybody miss? To really get why this paper is such a big deal, we have to talk about a massive billion-dollar flaw that's hiding at the heart of pretty much every single advanced AI model out there today. It's a kind of secret weakness they all share. Yup, you heard that right. It doesn't matter if you're using GPT-4, Gemini, or Claude. They're all built on a foundation that has this one critical limitation. I mean, they can do these incredible things, right? Amazing reasoning, creativity, but they are fundamentally brittle when it comes to learning new things over time. And that defect has a name: catastrophic forgetting. It sounds dramatic, but it's a simple and honestly a devastating problem. When you try to teach a model something new, what they call fine-tuning, it often just overwrites and completely destroys the skills it already had. It's kind of like learning how to code in Python, but completely forgetting how to speak your native language in the process. And here's the crucial difference between them and us. We learn stuff, we consolidate it, we build on it. Our knowledge is always growing. But for an AI, its knowledge is essentially frozen in time after its initial training. Any big update means a massive multi-million-dollar do-over, which, you guessed it, often triggers that same catastrophic forgetting we just talked about. And this is exactly the problem that Google's new paper says it and solve. The solution is this radical new idea, nested learning, and it's a complete rethink of how we should even be building AI in the first place. Okay, so here's the core concept. It says, stop thinking of an AI model as one big single brain. That's the old way. Instead, you need to see it as a system of systems, a whole collection of interconnected learners all nested inside each other, and, this is the key part, each one learns and updates at a different speed. For literally decades, AI researchers have treated the model's structure and its training as two totally separate problems. But nested learning says, nope, that's an illusion. The architecture itself is a learning system. The optimizer that trains it is also a learning system. They're all part of the same nested process, just moving at different speeds. And what's so cool about this, what's really fascinating, is how this new idea mirrors the most powerful learning machine we know of, our own brain. Think about it. Our brain has different systems for memory, right? You've got the hippocampus for fast learning, new faces, what you ate for breakfast. Then you have the cortex for slow learning, gradually taking all that new information and cementing it into long-term stable knowledge. Well, nested learning proposes the exact same kind of structure for AI. You have fast learners for what's happening right now in the moment, and then a whole spectrum of slower learners that lock that knowledge into the model's core memory over time, without just erasing what was there before. Okay, this all sounds amazing in theory, but does it actually work? Well, to prove it, the Google researchers built a model to test it out, and they named it Hope. Hope is built from the ground up on these nested learning ideas, and it can do something current models just can't. It literally modifies itself as you use it. We're not talking about some clever trick or fine-tuning. We're talking about genuine real-time learning from new data, without that catastrophic forgetting problem. So how did it do? Well, on a whole bunch of common sense reasoning tests, Hope was consistently more accurate than both standard transformers and other new architectures. So this shows the whole nested thing isn't just for memory. It actually makes the model a better thinker. And its memory? Also super impressive. In these needle and haystack tests, where you ask a model to find one tiny fact in a gigantic document, Hope showed way better memory management. That whole continuum of memory systems lets it find and recall information much more effectively. And finally, we have efficiency. This chart shows something called perplexity, which is basically just a fancy way of measuring how well a model predicts the next word. A lower score is better. And as you can see, Hope's score shows it learns language much more efficiently and with more stability. So yeah, the proof really is in the performance. So the early results from Hope are really promising, but let's zoom out. What happens if this nested learning idea actually scales up to the level of today's biggest models? Well, the implications are just massive. This is why this matters to you.
Imagine an AI assistant that actually remembers your conversations from months ago and learns your preferences without you having to spell it out every single time. This could mean the end of those insanely expensive retraining cycles for companies. We would finally move away from these static, frozen AI tools and start using truly dynamic systems that learn and grow right alongside us.
But okay, let's bring it back down to earth for a second. Like with any huge new idea, there's a pretty healthy debate going on. Is this a real revolution in the making, or is it just another brilliant research paper that's not going to scale?
The community is kind of split. On one side, you've got the believers who are saying this is the beginning of the post-transformer era, that this is the first time an AI model has truly been designed to work like the brain. But on the other side, you've got the skeptics. They're impressed, sure, but they're calling it a cute optimization paper and basically saying, call me when you get this working at the massive scale of something like GPT-4. And that leaves us with the big question. Is nested learning the first real crack in the just make it bigger philosophy that has dominated AI for the last few years? Is this the breakthrough that finally gets us to truly self-improving AI? Or is it a beautiful idea that's maybe just a few years and a few more breakthroughs away from really changing the world? I guess only time is going to tell.